Now let us move with the model 4, that is system commissioning. We know very well the system commissioning. When a PV cell or PV system is installed, commissioning is very important. There are many procedures which commissioning has to be done, and it produces PV system produces the electricity, and when it produces the electricity, it has to be interacted with the grid. And that time before that one, there are a lot of testing has to be done. So when installation has done, when the system is done with the installation, that the customer, before handing over to the customer, many types of testings are being done, are done. To inspect, testing is done, inspection is done, so that there should not be any complaint from the customer. So it has to compliance with the national and local standard and regulation. And safety also matters a lot. Safety has to be considered a lot, and we have to check the functioning of that particular system. So before that one, handing over the entire PV system, many testing commissioning is done, and then afterwards manual and handovers is given to the customers. So there are some standards which we uses, that is national standard for commissioning. Various countries have their own standards. They are having their own standards in this one. So that is first article, us article 690 is there, of national electric code, where some testings inspections has to be done before handing over the PV system. And international rules also there, like IEC 62446, where it shows testing, commissioning, inspection, documentation, everything has to be done. UK also is having its own rules and regulation in this one, and where it requires various testings as well as documentation. Australia and New Zealand, this also they are having their own rules and regulations, and they are having commissioning standards. Based on that standard, they have to done, they have to work. Canada, Singapore, this all countries, they are having their own rules and regulation. The final inspection of the system installation. The final inspection has to be done before handing over to the customer. Testing has to be done properly, and any fault, any problem occurs, then that it has to be addressed and switched. It has to be addressed properly. So the equipment and installation be checked properly. The equipment and component are not damaged. You have to see the designing document. You have to check the design document of the equipments are correct, and wiring also is correct. Equipment and component it should comply with the local standards, safety standards, and has to be interacted properly. The site, after completion of that one, the site has to be kept clean and tidy, and there should not be any hazardous material, and the signboard label has to be placed as per the local codes in this one. So after that one, the array or array frame which the PV cell is mounted on that one, in this one, it has to be inspected correctly, it has to be checked correctly, and it should be studied. And we have to check that, and there should not be any disturbance caused by the wind or snow and it should be a weather proof. Inverter plays very important role. So before commissioning is that one, before starting that one, inspection has to be done. For that also, connection has to be checked, why the wiring connection has to be checked. Location of the inverter should be considered, because it should be accessible for the maintenance and emergency disconnection, and it should be waterproof. For that one, waterproofing also should be there. Ventilation should be good in this one. The wiring and electrical component, that also should be inspected. It should be installed properly. It should be checked for mechanical and environment damage, and it has to follow the standards and regulation. In this one, checklist installation and pre-commissioning checklist they have given. You can see there are various type of things are there in this one. They will check all the things whatever are there in the PV system or equipment. They are going to check it all, and they'll make a checklist for like mounting flat on a roof, building integrity, and PV array tilted, solar array fixed. This is there. Then inverter, regarding inverter also, they will check the inverter whether local code, it requires local code, or isolate device, require isolate device in the mounting. This one is there. And whether they will check space and ventilation for inverter. Okay, yes or no, they will tick it in this one. Low voltage DC cabling, then identification is important, that also there. Then sign, a sign is required either on the white on the red. So the white letters, this is white letters are written on the red board, that is followed by the Australia's and New Zealand standards. You can see this one. In this one they have given this as a warning, dual supply for the PVC system, for the PVC system. And another, these are the mainly another checklist for this one. Permanently for main connector, disconnector, normal supply, means switches, PV array, mean switches. They check all the things how it is working or not. Like solar array on the loop, what is open voltage? This voltage, yes or no, they will take it. In this one, warning also, for that one also they kept a warning board also regarding this one. Warning boards also there, and total procedures they will write a shutdown procedure on that also. How turn off the inverter AC main located next to the output terminal. So they have given some procedures how to shut down the entire things in this one. And this is completely, it is signed by authorized person that he has checked, and all the system are as per the rules and regulation of local and national standards. Testing has to be done for the PV system, and there are many national code, local codes which has to be followed. For this one, there should be no voltage at the output of the PV arrays, and each thing has to be disconnected. Okay, any fuses has to be removed. Circuit breaker should be in off. AC DC main disconnector should be in off position, and the particular the inverter also should be in the off position. Safety plays very important role in this one. There are local codes that has to be fulfilled. Testing has to be undertaken. Isolator should be removed. Individually it has to be removed before starting before doing this one. Before starting testing, from it begins from array to the load point. Testing and testing is done in order for the safety. Risk is reduced. Damage, there should be no damage, and each step of parameters, and every parameter and meter parameters has to be checked using the meters, and it has to be checked properly. And if anything problem occurs, then the electrician should sort out the problem. The common things which has to be tested are continuity test between two resistors to component, then resistance of a cable insulation resistance is very important, it has to be checked. Measurement of array and string open, like open circuit voltage, that is also very important, it has to be checked. And short circuit current, that, and you can see this particular electrician, it is he is a testing the equipment using a meter. A meter has to be used, and various parameter, open circuit, short circuit, open circuit voltage, which is very important, but is not working, it has to give a various parameter has to be checked for this purpose. Then voltage drop across the fuses also, polarity, grounding of a system, that has to be checked properly. So these are the various checklist test sheet, pre-commissioning test sheet, which shows that the continuity between string and PV box, string 1 positive negative, this all has to be marked properly, it has to be checked properly. So correct polarity between string and PV box, this PV combiner box, that has to be checked in this one. So these are the sheets. Warning, in this one warning also is there. Open circuit voltage of string 1 has to be calculated, or string 2 3 has to be calculated. Continuity between PV combiner box and DC main has to be checked properly. The short circuit current also is there. Short circuit current, if we have to check properly in string 1, 2, 3, 3 of this one, and arrays open circuit voltage, that also inverters are there. Continuity between inverter and meter has to be checked. The line and neutral is there. They are shown the line. This all various things are there which has to be done properly and has to be using the testing sheet that they have to calculate. Commissioning, it is one of the process where after checking everything, we will switch on the PV system and the electricity is supplied to the grid. They have to abide by the national codes and standard codes for this one, and electrician should take care that as per the sheet given, testing sheet, everything has to be completed. So here you can see the commissioning test sheet where you can see a lot of things when inverter AC main disconnector isolator or DC mean has been turned on and inverter starts up the procedure. So that time the voltage at the input or at the inverter at the output of the inverter and various things has to be considered. System documentation, it is one of the important question in the exam also. And in this one what happen, you have to follow the what are the documentation should be given. So the list, some list of the documentation they have been given. Let us uh, go through this one. First, the list of equipment supplied. See, whatever the equipment is having, whether it is an inverter or whether it is an array frame, modules, PV combiner box, strings, isolator, fuses, or circuit breaker. The list has to be provided to the owner. Next comes the system design. In system design, a wiring design, particularly wiring design, where it is connected, how it is connected, that has to be given. Performance estimation. See, what happened when they are handing over the PVC system, then they have to give the what is the performance of the system depending upon calculated by the designers. Designer calculated some value, so they have to give this is estimation estimated performance 90%, 95%. They have to give, and this one what are the savings they will do in the electric will indicating that there might be change yearly wise. Then operating instruction in the system manuals has to be provided to the owners which indicate how it works, how it operates, information regarding that equipment. It has to be given and it has to be told that the system stop, turn off when the grid fail, shut down an isolation procedure for emergencies and maintenance. Manual should be provided if something emergencies happen or any maintenance is there, how the maintenance has to be done, so how the complete shutdown has to be done. All the procedures has to be given in that one. Maintenance procedure also is very important. What are the various maintenance in this one? They have to give. Then installation and commissioning records, whatever they have done, whatever the testing they have done, by signing that they have to give. Monitoring system, inverter has to be monitored properly. So the manufacturer has to provide the monitoring manual to the owner so that it can be monitored. Warranties, there are many types of warranties in this one. The first comes the product warranty covering defect in the manufacture. Second is related to output performance. Third is related to proper operation of installed system, and fourth is energy performance or related to the guarantee energy. So these two first two warranties of a manufacturer, if any defect happens or anything happens, then it can be exchanged.